Okay, so this is the most complicated family tree thing that I could find for you to follow through. I would really hope that you wouldn't get anything quite as curvebally as this. So we've got two things going on here. We've got the allele for Rhesus positive dominant to that for Rhesus negative. So we've got this Rhesus positive, big R, Rhesus negative, little r. Haemophilia, so we know that that's sex-linked. That immediately see that, you know it's sex-linked. And it says that haemophilia gene is recessive to that for normal and is on the X chromosome. The diagram shows the rhesus blood phenotypes where some individuals have haemophilia. So we've got our haemophiliacs are coloured in or not, as in the normal way. But then we've also got this sort of rhesus negative thing going on, so we're looking at two different characteristics. So I'm just going to highlight my rhesus negatives, who are my recessive individuals. So we've only got 3 of them on the tree. And the reason I've sort of highlighted those is just to make them stand out. Obviously the haemophiliacs do stand out because they're coloured in, but the rhesus negatives don't. So, use the information in the diagram, one piece of evidence, here we go again, that the allele for rhesus negative is recessive. So my one piece of evidence, I've got 3 rhesus negative people. Both of these parents are rhesus positive, both of these parents are rhesus positive. That's our main evidence, isn't it, for recessiveness, that 2 rhesus positive parents give rise to a rhesus negative child. So, individuals, doesn't matter which one you choose. I'm going to choose 10 and 11 this time. 10 and 11 are both rhesus positive. And have a rhesus negative child. Explain the evidence from the cross between individuals 3 and 4. So they're already giving us what we're looking at, that the gene is not sex-linked. So individuals 3 and 4, she's unaffected and he is, no, we're just looking at rhesus positive, aren't we? So rhesus positive, they've got a rhesus negative child who's got to be that. If it was sex-linked, you'd have to have a rhesus negative father, yeah, because it would have to be that, and he would therefore have to be that to pass on his rhesus negative, but he's not, he's rhesus positive. So individual 4 is rhesus positive. If it was sex-linked, individual 8 would have to inherit a rhesus negative X chromosome. Oh, chromosome from her father. Okay. Phew. That's always the trickiest one, I think, to explain. So, give the full genotype. So, full. That means haemophilia and so the H and the R alleles. So individual 6, let's have a look at individual 6. Individual 6 is positive, but individual 6 has a negative father, so has inherited the little r allele from her negative father, but the big R allele from her positive mother. Not affected by haemophilia, so she's got actually one X big H at least. So now then, we've got this haemophiliac down here who has inherited the X little h from mum here, so individual 10 is X big H, X little h. She has inherited an unaffected X chromosome from dad 7, so that means that her other X chromosome must be from mum 6. That's awful, isn't it? That I made you work back through 3 generations. But anyway, there we go, we're there. So X little h. And individual 12, of course, is Rhesus negative, little r, and then we've got, he's an XY, and he's haemophiliac, so he's got the X little h. Okay, what is the probability that the next child of couple 10 and 11 will have the same genotype as their first child? Well, this is an absolute swine, isn't it? Because 10 and 11, we need to do the Rhesus positive and the Rhesus negative thing, so it's a dihybrid cross with sex linkage. Swines. I'm going to do the cross in this little gap down here, so that I've shown my working. So I want to fill all my liney space up if I need to do some explaining. I don't know whether I do. I know, I only need the probability, don't I? So, 10 and 11. So, 10 is Rhesus positive, but they've got a Rhesus negative child. So we've got RR, X big H, X little h, crossed with, he's got to be heterozygous as well for Rhesus, because they've got Rhesus negative, and he's unaffected by haemophilia and is male. Brilliant. So I need to now, I'm doing a dihybrid cross, aren't I? I need to foil my genotypes out of my gametes. So I've got big R, first XH, X big H, that's one gamete. Last R, X little h. And then I've got little r inside X big H, and I've got little r, last letter, X little h. Swiney, horrible cross. So father is X, R, first letter X big H. Outside RY, little r X big H, and little ry. Let's put them into a Punnett square, got handy lines to write on. So, producing two sorts of gametes. So, oh no, crikey, 16, good lord, 4 types of gametes for each. Thinking properly. So R X big H, RY, R X big H, RY, R X big H, R X little h, little r X big H, little r X little h. do you know what, I don't fancy filling this in. So I'm only interested if the child is Rhesus negative, because it's the probability of the next child. So I'm just going to apply a bit of logic here. So my little R alleles are there and there. RR, 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 RR. Brilliant. So I'm only interested in the ones with the same genotype. So I'm only interested in the Rhesus negative ones. So I only need to look at these 4. That cuts it down a bit. I could obviously fill in all the rest of it, and that would be a lovely exercise in writing lots of letters out. And I'm only interested in the boys. So I'm only interested in the ones that are going to inherit a Y chromosome. So these 2. X, big H, X, little h. So this one, that's the one I'm interested in. He's the one that's got the same genotype as individual 12. So my answer is 1 out of 16. That's the probability that next child is little r, x, big H, y. And I can work out what that is if I need to. So 1 divided by, because I've always got a calculator, times 100. So it's 6.25%, could be one of my answers. Excellent. Job's a good one. So even though it looked quite hideous, and my sort of heart sank when I got my 4 types of gametes for each parent, realising that I only needed the Rhesus negative boys made it a lot easier. So I'm not going to fill in the rest of it, too lazy. Oh, it's still going.